the student would can join. All right. Okay. Before we start, then maybe I can start recording first. Just few seconds.
This call is now being
All right.
recorded.
So, good afternoon again, everyone. So, how are you? Good, everybody? Okay, I hope everyone is excited, all right, to hear what we are going to share today. So, today we are honored actually to have an invited speaker. Let me introduce to you Dr. Intan Zikria. Dr. Intan, she is an esteemed lecturer from Department of Information System and Technology, okay, from Universitas 17 Agustus 1945 Surabaya. Okay, so she's from Surabaya, Indonesia. Okay, so nice to meet you, Dr. Intan, again.
Nice to meet you too.
Okay, so Dr. Intan will give an interesting talk about human-computer interaction in embedded system. So it's very related to your course, right? So Dr. Intan is actually not new to UNIMAP. Okay, so she has been here before in June, I think, if I'm not mistaken.
Yes.
Okay, so we have also been collaborating with Dr. Intan, okay, through our Center of Excellence for Advanced Computing, AdvancedCom. All right, and then I believe Dr. Intan also have few projects with our researchers here in UNIMAP. Okay, so for your information, Dr. Intan, so this course is embedded software technology. Okay, so this course is actually taken by third year students, okay, and some of them from second year. And this course is led by Dr. Siti Julia. So Dr. Siti is also here, Dr. Julia. She's with us today. And this course has lecture and also 3 hours lab. So during the lab, students has hands-on experience on how to set up the embedded system. Okay, so before we hear about Dr. Intan interesting talk, let me first introduce to students about your background. Okay. So, guys, Dr. Intan has successfully completed her PhD in 2020 from Department of Information Management at National Taiwan University of Science and Technology. And then this is also where she obtained her degree. And then her professional experience include engagement at Wilmore International Plantation, Jakarta, and founding an international startup managing blockchain-like technology known as Halal Taiwan. And then presently, she actually a lecturer at the Department of Information System and Technology at UNTAD, Surabaya, and is soon to be an associate professor. Okay, so in 2016, Dr. Intan took a role as the head of curricular development and evaluation within the department and served as the secretary of internal audit in the University Foundation. Okay. And then furthermore, she obtained a certified risk management professional certification earlier this year. Her primary research interests, okay, includes human-computer interaction, okay, IT risk management and software engineering. Okay, so this particularly exploring the impact of technology adoption on human behavior. All right, so today Dr. Yuntan will enlighten us on the topic of human-computer interaction in embedded system. Okay, so guys, so please hear Dr. Intan's talk, and then later on you can ask her questions. Okay, so without further delay, I will now invite Dr. Intan to commence her presentation. Okay, so Dr. Intan, the platform is yours. Thank you.
Thank you. Wow, when you read my biography, it looks like I'm so I don't know what to say about that. Okay. Thank you, Dr. Naima. And this is our like I don't know how many times we have met before, and
Yeah.
it's my pleasure to actually join with in your class today and meet your students to share about human-computer interaction in embedded systems. So maybe can I share my presentation
Yeah,
today?
sure, sure.
All right, wait a minute. All right. Can you see my presentation?
Yes, I can see. How about students? Should be okay, right? Okay, doctor.
Okay.
You can start. Thank you. Yes.
Okay. So before I start, I'm going to introduce myself again. Hello, everyone. My name is Intan Zikria. You can call me Miss Intan. Okay. And I'm actually still very new. I mean, my PhD, I just graduated from Taiwan in 2022, like late 2022, and active as a lecturer in 2021. And I started to know Unimap, I think it's about 2022, in the mid of 2022, I think. At that time, Professor Badli Shah Ahmad came to our university and have a talk, and I became his let's just say guide, his guide when he was in Surabaya at that time, and then we become closer. And so when we have opportunity to came to Malaysia, we we planned the lecture. So I had a lecture in Unimap in July to talk about HCI also in human computer interaction, because that's my research area. And it's actually very interesting because computer interaction right now is not only about computer, but also about other systems and about hardware and software. And specifically for today's talk, it's about the embedded system. But before we talk further about the human-computer interaction within the area of embedded systems, I want to let's discuss first about what is HCI. Have you ever heard about HCI before, about human-computer interaction? Is there anyone who actually ever heard about it?
Students, have you heard about the HCI before?
Maybe you can raise your hand if you're shy. Oh, I'm not sure. There's someone who actually say I'm not sure. Okay, I'm going to explain it to you like a general explanation about HCI. Yeah? So the definition of HCI is more like a multidisciplinary field of study focusing on the design of computer technology, and in particular the interaction between humans and computers. So the key point in here is the multidisciplinary field of study. So it's not only about computer science, it's not only about electrical engineering in a part, or it's not only about psychology, because usually interaction is more into the psychology thing, right? But SCI is the multidisciplinary field of study that focusing more into the interaction between humans as the users and the computers. And currently, computers is not only about computer, but also about the other systems related with the computing. And the multidisciplinary field of study in the SCI research area is around computer science, cognitive science, and human factor engineering. In here, you can see that actually in the field of SCI, there are so many fields or area of study. So it's not only about the how we create the computer or a system that can be interacted with the human very smoothly, but also we talk about the psychology of the user when they use the system, and then about how we design the product, because right now SCI is not only about the software but also about embedded systems that we put into a hardware, and how we design the product of a hardware itself so that it can be used easily by the users. And we also talk about the anthropology of the users, sociology, computer vision, speech recognition, robotics, motion design, spatial experience, and any other stuff like fields of SEI. Yeah? And the goals for research in ACI is more into the evaluation or comparison of existing systems or features. So we research the, like for example, there are several systems, the existing and the previous systems, and then we evaluate the existing systems whether the system actually very good to handle the user interaction, and we can compare it with any other systems or features so that we can create a better system for users. And then the second goal is to invent or design of new systems or features that is determining what the new system should do and how. Because usually when we talk about SEI, we know about the characteristics of users. So sometimes users say, oh, this design is not good. Maybe like, for example, the color should be green, or is the color should be blue. But then our company that create the design of the new systems think that, oh no, the color should be red. But us as a creator of a system, we have to listen to our users, right? So when we listen to our users, we can determine what the system should have or do and how we do it. And then the third goal is to discover and testing relevant scientific principles. Sometimes at CI have many theories, like for example, theory of technology acceptance model, and then unified technology of acceptance, and also other models that can be used for discovering and testing whether the models can be used for a specific use case. Case study, for specific case studies for the user interaction. And then the fourth goal is to establish guidelines and standards. Normally, when we establish guidelines and standards, we have to comply with the guidelines, right? So for example, if we want to create an app for Android, we can use the Google Material. Google actually have a specific standard, a guideline for the developers to create Android products, even not only in the mobile phone, but also in the desktop app, something like that. For example, it's also they guide us about the coloring, and then the alignment, layout, and everything else. And when we use those guidelines, sometimes it's difficult for developer to follow it. So we have to create a new guideline or standards for us to create a system. So this is the goals for research in SEI. So today's focus is to the human interaction with embedded systems. Yeah, this is the today's focus, because we are not only talk about the software only, or how human interact with a software, but we focus on the embedded systems. So before I go into deeper topic, let's discuss. Raise your hand if you use embedded systems. Please raise your hands. Wow. Okay. How many students? Wait, let me check. There are a lot. Not a lot, but okay, maybe 10, 12, yeah. Students actually ever use embedded systems before. Very good. And maybe is there anyone who can give your opinion about what are the examples of embedded systems that we can find on daily basis? Any example? Is there anyone? Come on, don't be shy.
Yeah, you can also actually you can also type on the chat box. Okay.
Yeah, type the chat box. Okay.
The application that actually you have been doing in the lab and also learn during the lecture. So just give example.
Smartphone, printers. All right. Yeah, good. Printers, smartphone, phone.
Trees.
MP3s. Yeah. Okay. Any other thing maybe? Embedded systems? Lappy.
GPS.
Yeah. GPS is one of the sensor. Yeah? So GPS is built in our devices like laptop, and then in our mobile phone, or maybe like wearables. I wear wearables here like smartwatch. And there are a lot of embedded systems that we can find on daily basis. But it's just that some people, most people, they don't think like they never thought that it has embedded system, right? So for example, if we drive a car or driving our scooters, yeah, and maybe when we use our camera, yeah, then someone else will say camera here, digital camera. um we've never thought about the embedded systems inside those devices that we use, or like for example car. Is there any embedded systems in the car? Yes, of course there is, because right now, especially like the modern cars, they have software, they have systems that is embedded into the car so that it can be used by our users, like the car users, for safety, for example. And so the first keyword in here that we will discuss is about embedded system first. Yeah, I believe that you already learned about embedded systems from Dr. Naima, and you know about all of these things. But let's have a generic discussion first. Yeah. So the first definition of embedded systems is like embedded systems are specialized computing systems, combination of hardware and software designed to perform specific dedicated functions within a larger system. Yeah, and these systems are found in various devices and appliances. So it's not only like a very simple gadgets, like in appliances, like in home appliances, like a microwave ovens, for example, or digital watch, like smartwatch, but also very complex systems like medical equipment, automotive control systems, and also industrial machinery. And we have to break our assumption that embedded systems only are in the complex systems. But very small, very simple gadgets also have embedded systems. Yeah. There are five key characteristics of embedded systems. The first one is dedicated functionalities. It means that each system has its own very specific functionality. For example, if we build an embedded system inside a car, then the functionality is more into the car itself. It's not going to be used for a scooter, or it cannot be used for our day-to-day basis when we use like a laptop or something. So it's very specific functionalities. And then the second one is that it has the integration between hardware and software. Like I said before, it's not only software, it's not only hardware, but it's both, the integration of both. And then the third one is the limited resources, because it has a specific functionality. Usually, it's embedded into a specific hardware. The limited resources in here is more into like the energy consumption, like for example battery. They have a very limited battery life for embedded systems, so they need support for that. And then the fourth one is about the real-time operation. So right now, if we talk about embedded systems that is not real time, it will be very difficult for users to handle. For instance, like if we if we have an embedded system inside the car, so the system must have a capability to learn about the surrounding area of a car and how the car is operate, so that when they have an impact, like an accident or something, they can automatically react toward the condition. So it must be real time. If we imagine an embedded system that is not real time, it's very unusable, I can say. Yeah, it's unusable, because currently everything is connected, everything is online, and even though it's not online, like for example it's a batch processing, for example, it's not online, it's better for the systems to be real time. And then the fifth characteristic is that it can be implemented into various applications. It's not only like in small gadgets, but also in a very complex systems, like a medical equipments, and then maybe in military, yeah, in military airplane, in the train, or in like ERP system, like enterprise resource planning systems, and Internet of Things. it can be combined into a lot of applications that can help a lot of people. There are several types of embedded systems. So let's talk about the first type. It's about real-time embedded systems. The definition is that a subset of embedded computing that must complete critical processes within a rigid deadline. And the examples are, I have two examples in here. The first one is engine control management inside the car, because it must be real time, right? If not, then how can the safety control can turn on when there's an accident? It must be real time. And also the second one is avionic system. It's for the airplane. Yeah, if the airplane is not real time, it will be dangerous. It will be very dangerous. How about they communicate with the operator on the land about their landing, for example? So it must be real time. And the second type is about network embedded systems. Sorry, I have to drink first. Okay. So the second type is about the network embedded systems. These embedded systems connect through networks. As you might know already, it's about Internet of Things devices, where there are multiple devices that can communicate and interact with each other. Even it's not only in the internal environment, but also with the external systems also. For example, like we talk about smart home, for example. The home itself can be connected with our wearables like smartwatch, and then connect with our television, and maybe some of home appliances like oven, and then refrigerator, and the laptops, and maybe some lights, lamps, digital camera, and then something else. But it can also be interacted with other external environment, like for example the car, and also CCTV around the home. How to say that? Like there are like in the area of homes, a lot of homes in a small area, right? And also another example is about connected vehicles. Right now, it's already implemented that each vehicles, like a modern vehicles, they have embedded systems that can be connected with other cars, or even if they cannot be connected, at least the system can detect where other vehicles around them, not only vehicles but also objects, so that they will not going to um, have a accident with the people passing by, for example. And it is very it is very connected, it is very network. If it doesn't have any connection at all in the car, then the system cannot work. And the third type is about mobile embedded systems. As you know, as in the term of mobile, then it must be mobile. It's not only about smartphones, tablets, wearables like smartwatch or GPS systems, but also like devices for gaming, like mobile gaming devices like this one. This is like Nintendo. Yeah? We the problem is that it has constraint. It has constraint that related to power consumption and size, because like mobile embedded system must be small. It must be small. If it's too big, then it's not mobile. It must be small. The next type is the standalone embedded system. As you know from the previous topic, that the characteristic of embedded system, one of the characteristic is that it must be how to say, like it must be very specific in functionality. Yeah, it must be specific in functionality. It's just, if for example, if you want to build a smart fridge, inside the smart fridge there is a system to control the fridge, to understand what's inside the fridge, for example. And inside the digital camera, there is a function for capturing the pictures around us, right? So those specific functionalities can be only used in that devices. So it can be that is why it's called standalone embedded systems, because it operates independently, performing specific functions without relying on external connectivity or interaction. If they so basically they don't have to have internet. to to operate, but they have a system inside it to help for the process that they do. And there are several technologies behind embedded system. The first one is about the microcontrollers and microprocessors, because without these two, then the hardware cannot work. And then the second technology is about sensors and actuators. Sensors is the thing that sense the environment, and actuators is the thing that act upon the senses. Yeah. And then the real-time operating systems, also communication protocols like internet, cloud computing, or maybe batch processing, or OLAP, and memories technology, and also security measures. Because embedded systems usually they have like a small little holes inside the system that if they are not protected, then people that have a bad intention can hack into the system. For example, if you build a smart home and then you don't put like a very good security measures, like bad people can go into your home just by hacking your system, and it's not good, right? So you gotta prepare for the security measurement for the embedded systems. Let's discuss, okay? Why, from those examples, we can see that the implementation of embedded systems are so many, and a lot of people actually use embedded system without them realizing that inside the devices it has embedded system. The question is, why people like to use embedded systems? Is there anyone? Okay, let me see the message. Makes life easier. Correct. Makes life easier. Anyone maybe want to give some another reason why people like to use embedded system other than making our life easier? Anyone? Why people like to use embedded system? It's true that embedded system can make our life easier. It's true. But another reason is that because the embedded system is easy to use. It's very easy to use. Even like sometimes people don't really aware that what they use is actually embedded systems, right? They don't really aware that. They don't, and and that's the purpose. The purpose of embedded technology is that if users doesn't really know that the device they use actually has embedded system, it means that the system actually works. It's success. Because they want to use it again and again and again. They don't think it like a software. They only think it as a hardware. They don't know that it has an embedded system inside. So because it's easy, it's very easy to use. And this is, yes, it's true that the Ashwin say that it's for advanced technology. Yeah, it's true. But embedded systems have a lot of technologies. Advanced technologies right now is very broad. When we talk embedded system, it means that it's not only we don't talk about not only talking about Internet of Things. We also talk about cloud computing. We also talk about artificial intelligence, machine learning, and then robotics, and about, like, for example, SDN, software-defined networks, and other advanced technology that we can put into the embedded systems itself. Yeah. So the second keyword is about human embedded systems interaction. The key of HCI, because HCI is a broad field of study, human computer interaction. As I told you before, computer is not only about computer, and this time we change that into human embedded system interaction. Okay, that's the second keyword. So currently, like for the past 5 years, HCI research concerning embedded systems focuses on the understanding and improving the interaction between users and devices with embedded technology. Understanding and improving. interaction. So we gotta understand first, because before we improve the interaction, right? We gotta understand first. And the research interests in more into the UI design and then usability and UX and context-aware computing, wearable technology interactions, gesture and motion control, accessibility, privacy and security, also collaborative and multi-device interaction. So these are the 8 most famous research interests for the HCI in embedded systems. Let's talk about one by one, yeah? One by one. User interface design. I try actually to, how to say, find out many research for the past maybe about 10 years, yeah, past 10 years about the HCI on the user interface design. So the research of UI design is more into the designing of intuitive and user-friendly interfaces for embedded systems. Considering that embedded systems usually small, because we gotta put systems right into the small hardware. So the display size is very limited, and the input options are also limited. And the design of the UI of embedded systems is involving how we explore very novel ways to present information and interact with the system efficiently. For example, like this research of smart home by Oniga, the research paper of Oniga in 2010. This is the design of a smart home for the control and monitoring platform. They actually propose design for how the computer can connect with other sensors and also the actuators, and also have how the interface can help users to understand what they have in their home. And this is the result of the paper research paper. And the second one is the research of ZDEC in 2017. They studied about the web user interface for machine learning on embedded systems. As you know, like if we want to build a system that use machine learning, it's very difficult for us to understand what the machine capable of. It's very difficult. So what they do is trying to create a user interface, yeah, like web based, and then how can users know what the machine actually learn inside the embedded system. So for example, like if we put an embedded system into our smartwatch, for example, and there is a machine learning there, the machine learning want to learn about our statistic behavior. I mean, our psychology from the stress level by using, how to say, from our wrist, there is a heartbeat, right? They get it from that, and then they want to learn about it. But how can the researcher or the company know about the behavior of learning? And this is very difficult to understand actually how the machine actually learning. So they create a web user interface for that. The second research focus is about the usability and user experience. The research studying how users interact with embedded devices to enhance usability, satisfaction, and overall experience, and this includes evaluating interface, understanding user behavior, and optimizing designs based on user feedback. For example, this is the research result from a paper in 2016. The author is Chua, and the authors actually studied about the impact of whether wearable technologies like smartwatch, for example, uh, have the have the impact between the technology and innovation to perceive usefulness and feasibility. The results show that technology actually have an impact, very high impact to the perceived usefulness, but not to the feasibility. But the fashion actually have impact to feasibility. We thought that technology maybe have an impact to feasibility, but no. Technology only have impact to usefulness. But fashion to the feasibility, but not to the usefulness. And this is a very good result, yeah, for the research or to the people to understand how users like their smartwatch, how they want to use smartwatch again and again, or maybe become a loyal customer, so that when there is a new update on the device, like for example, like iWatch usually have several version, right? They want to change to the new version. Why? And this is one of the results of the research that can be used to understand that. And there are a lot of research about this. How we can understand the technology, how can we understand the not only the software but also the hardware. Because embedded system is not only about how high tech you are, but how you create a device, the hardware that actually very nice, very aesthetic. If not aesthetic, if it's not fashionable enough, then no one want to use your device. Just like in a car, if your car is not good enough, like the visual of the car is not good, it's not aesthetic, even the car is very very high tech, like have a very good embedded systems, no one will buy the car, right? And the third research focus is about the context-aware computing. So the research is focusing more into the developing systems that can adapt their behavior based on the user's context, location, preference, and activities. And this area actually explores how embedded systems can intelligently respond to changes into the environment or user needs. More, for example, this one is it's called the research of last year, 2022. I found the paper. It's about flexible manufacturing systems or FMS, and they talk about how the manufacturing machinery they can interact or they can respond to the condition of other machine intelligently. So without the need of human control. So basically, it has machine learning, it has robotics, it also have AI, big data, and everything else to create a flexible manufacturing system. So the computing itself is aware of the surrounding, the location, about the preferences, about the activities. I think currently our wearable devices, like for example smartwatch, the very new smartwatch, they already input context-aware computing. So when the users, for example, I experienced this myself. For example, when I sit down too long, they know that I sit down too long. They know, so they just like remind me from my race that hey, stand up now. Stand up now. It's called context aware. It's called context aware. They know that we are sitting down even though like our hand is moving, where we are sitting down our hand is moving, but the device know that our leg is not moving. How can they know that? That is called context aware. Yeah. And then the next research is about the wearable technology interactions. The focus is more to investigate interactions with wearable embedded devices such as smartwatch, fitness trackers, and also augmented reality glasses, AR glasses, focusing on comfort, usability, and integration into daily life. So, for example, for this kind of research in 2023, it's just released, yeah, published. The paper is called User Experience of Augmented Reality Glasses Based Tele-Exercise in Elderly Women. Yeah, so they want to know whether AR glasses actually good for elderly women. And the result shows that the elderly woman can actually uh, become more dependent, and they have a high efficiency rate if they are not using AR, but instead they use tablet. So for now, AR glasses is not good for elderly women, but it's good for maybe the younger age generation. Although when they have this research, when I read a paper, it's more about the capability of elderly women to see because they have a limitation in their eyesight, right? So if they use AR glasses, then they don't need to put their tablet in front of their faces like this. Yeah, but the problem is that it's not easy to use AR glasses. It's not easy. They are more dependent, have a dependability into tablet rather than to AR. The next research is about gesture and motion control. The research more focused on the exploring natural and intuitive ways for users to interact with embedded systems, such as using gestures, physical gestures, motion sensors, or voice commands, and especially in scenarios where physical interaction is limited, and usually this is for the disability people. And for example, like in this paper, they talk about the game strategies for the post-stroke patient. Like stroke patients, they cannot move their body like before, right? For example, they have a disability in their hand or in their leg or maybe in their face. So, but they like to play games. They want to play games normally. So how we can help them, right? How can we help them? So we create a very good hardware. Like for example, this is actually their hardware. They put the screen in here. This is the screen of the game, and then they also put some stuff here so that the user, he actually has disability after post stroke, they can play the game using the, how to say this, it's like a rotator or something. Yeah, they can play that in here. So we want to, we research how we can help them using this kind of research. And then another research is about the accessibility. We want to make sure that the embedded systems are accessible to users with diverse abilities and needs. So not only people with normal way of life, but also disabilities and also kids and everything else. So even like mental health disabilities, like what this paper actually talked about. In 2019, they research about the willingness of people with mental health disabilities to travel in driverless vehicles. So we know like there are a lot of driverless vehicles, right? But it's kind of worrying. In a way, I don't think that I want to ride a car that can move by themselves. It's very it's very weird. It's very frightening. But the research shows that driverless vehicles actually can help people with mental health disabilities because when they have these kind of disabilities, usually the symptoms will come out immediately when they are on the way, and it's very very frightening if they have accident, right? So it will be very helpful for them, but they want to learn first whether are they like are these people actually want to use the driverless vehicles. And the the research more focusing on the factors that have impact to the freedom, fear, curiosity of the people toward the willingness to travel in an AV, yeah, or the automated vehicles. It's very interesting actually if you read the paper. Other research is about privacy and security, and this is more into the understanding user concerns about data privacy and security in embedded systems. And this focus more into the design that protect user data while maintaining functionality. Usually, for example, like this one, they investigate how the smart home security is having, like holes, and we gotta close the holes using blockchain. Yeah, using blockchain. Another research focus is about the collaborative and multi-device interaction. This is studying how embedded systems collaborate with other devices and platforms to create seamless user experiences, such as interactions between smartphones, IoT devices, and home automation system. And this is the industry-based evaluation from this, like in the research of 2019. They actually explored the key services and players in the smart car market. The result shows that the interaction right now is not only about one devices, but we can interact with several devices together. For example, when we talk about the vehicle, like automated vehicle, it's not only about the vehicle itself that has embedded system, but also all other applications that can be installed into our smartphone and also in our home. For example, if you have a driverless car, then and we also have smart home, then both home and car can interact with each other. And also there is a applications like financial technologies that can also interact with our car in a way, something like that. And okay, those are the things that HCI focus, research focus on embedded systems. Is there anyone who can give some idea about what other topics that are interesting for the next HCI research, maybe from the examples that I give you?
All right, anyone would like to probably suggest or really come across your mind just now that you would like to relate with the HCI? Or you think that need the HCI?
Actually, I have maybe as an example for you. I just have an idea. Um, how about I have a Pikachu here. You see, I have a Pikachu here. This is the Lego block that I
So
have.
cute, Doctor.
Yeah, I like this cute stuff. In my desk, I have this. And what if put an embedded system into the Pikachu? What can Pikachu do for me when I work? Maybe he can tell me, he or she, it can tell me, the Pikachu can tell me that, hey, Intan, it's time for you to rest because you already worked for more than 2 hours, for example.
It could be smart Pikachu then.
Yeah,
Not
smart
smart.
Pikachu. It can be robot, for example, something like that. And it will be very, very nice to have because it can increase our productivity and health level, right? For example, something like that. So, what do you think, guys? Do you have any ideas about embedded systems, maybe?
Probably you can think of something interesting to work with the HCI. Now you know about the HCI, right? Okay, guys?
Why no one wants to talk? I think it's the same as my students in here.
Same, same, same culture. Don't be shy, guys. Dr. Intan is very nice. You can
Yeah,
see from
I'm
here.
not.
He's the
I'm
top.
not going to bite.
Very shy, Anik. In the class, you don't shy. You are not shy. Just type maybe. You are going to be one of the future developers. So you should think of something interesting to, work with the HCI. Wow.
Neuroadaptive interfaces. Wow,
What
this
is
is a
that?
very high tech, but but it's not wrong. It's not wrong. Neuroadaptive interfaces. Yes, it's not wrong, and it's currently it's very the research actually is still ongoing, and I have a friend that he has this as his research focus. So when we talk neuroadaptive interfaces, we gotta understand about the technology behind the neuroadaptive interfaces because it has hardware to get our signal, the brain signal first. But then, how can we contribute it into the embedded system? Is it is the device can be like a chip and then put it in our brain, for example? Or when we use like Oculus, Oculus, the glasses, AR glasses. When we use that, our users can, the AR glasses can get our brain signal to play games, and whether the users agree with the data gathered. Are the users okay with their data to be used for the game, for example? And that's part of the topic of the ACI research. We want to know what users actually think about the system, what they like, what they want to do with the system, and those are the very fundamental research topics of ACI. And it's not easy. It's not easy to for the neural adaptive interfaces. It's not easy because uh, the respondents of the research, it must be like a lot. Yeah, it must be a lot. All right. So that's our topic for today, and this time is discussion time. So please, anyone, if you have any question, please.
All right. Anything that you'd like to ask Dr. Intan? So please, guys. Anyone?
Anyone? Don't worry.
There's one question.
There's one actually asking. Does AI threaten SCI? No. The answer is no. AI is not threatening SCI. SCI is a field of study. It's a research area, human-computer interaction, and AI is part of it. AI is part of the SCI. So, for example, if we talk about human-computer interaction, the computer itself can be changed into a robot, human-robot interaction, because robot is a computer, right? So inside the robot there is an AI. So how humans interact? How humans interact with AI? That's the field of study in SCI. So AI is not threatening SCI, but it's more like of another topic area, research area in SCI field of study. Okay. Anyone else want to ask their questions? Maybe want to discuss something?
Dr. Intan, while waiting for students maybe to create questions, I actually was wondering because we can see now that actually the HCI has offered amazing benefits, okay, to various applications, okay, and technology. So this includes, I think, what you have mentioned before about the smartwatch and smartphone, everything, right? The embedded system. But I was just, wondering about the autonomous vehicle, okay, because there are a lot of controversial issues lah regarding the autonomous vehicle, like right. So we have also seen recently that this autonomous vehicle have actually um, uh, hit a woman in New York, I think, if I'm not mistaken, of San Francisco just 2 months ago. And this is not the first time. So, how do you think the HCI can help in solving this issue lah? Because as we know, autonomous car is doesn't have any feelings, it's all autonomous, right? So probably HCI can do something on this. What do you think?
Yeah. So thank you about the question. It's very interesting. Yeah, I know about that news, and there are a lot of things like accidents happen toward the AV or automated vehicles. It's true. So how can we prevent that using HCI research? What we can do is that to understand first the behavior of the vehicle. So the behavior first of the vehicle, whether the vehicle actually have enough sensors to sense the environment,
Mhm.
because the environment is not only the front and the back, but also the right and left, and also the upper side of the vehicles, right? And the area around surrounding the vehicles, whether it has enough sensors. That's the first thing. And then the second thing is that about the pattern recognition, because when we inside the autonomous vehicles, they have the sensors to understand the pattern or image around the vehicle itself, right? If there is a something, some objects near them, and the research of that, like the technology of the pattern recognition, is part of AI, artificial intelligence. So I think that more into the technology itself to detect an object. But for the HCI research to help those accidents happen, we gotta understand about human behavior too.
Mm.
We have to know like why people like to how people like to cross the streets, for
Mhm.
example,
Mhm.
and why people in a specific area of a country they like to passing the streets without waiting for the red lights, for example,
Yeah.
something like that.
Mhm.
And each country have their own cultures of people on the street.
Right? Yeah, different rules.
They have different rules, and we gotta know that. We gotta understand that, and that's those understanding from the SCI research can be included into the research of the vehicle itself. I mean, to the implementation of the vehicles. So the SCI can help into the development of a vehicle that actually safer by including the human psychology into the implementation.
Interesting, Doctor. Because the fact that this HCI actually can help reduce the incidents, accidents, right? Of course, we know that the EV, the AV, it cannot react immediately because it is programmed, right?
Yeah.
And of course, there are a lot of sensors, but still accident happens. So I think this would be one of the interesting research lah if it can integrate with the AV, right?
Hmm.
Hmm.
Yeah.
Because I think they have also done a lot of things to solve this issue, but still accident happens. Okay, there is one question. Thank you, Dr. Intan, for the
Yeah.
answer.
Welcome.
One more question from the student.
Which is most popular in the industry, HCI or AI? Okay, it cannot be compared. I can say it cannot be compared because it's like comparing AI with robotics. It's like comparing AI with robotics because AI is part of the robotics and AI is part of the ACI research field. So, which is more popular in the industry? Both are popular. However, if we talk about which is most popular in the academic research, whether is it SCI or AI, the most popular is AI. That's the fact. AI is most popular because um, the research is kind of the research and the implementation is more into the technical implementation and about the algorithm or maybe the connection of AI with other technologies, something like that. But for HCI itself, because it's a multidisciplinary study, right? So not everyone understand the psychology of a human to be included into the technology itself. So before we analyze the HCI, before we go deeper into the SCI, we gotta know about the psychology first, like the theory of psychology, and then we how to say like we understand the behavior, and then we observe more about people, and then we read about how human interact with their surroundings, and after that we put those observations into the area of technology. So that's the difference. Okay. Oh, another one. What are some of the challenges faced in the HCI field today? I think it depends on the topic. It depends on the topic. But the most challenging thing is to have respondents. Like, let's see, I usually using survey or like trying a new technology trial. Yeah, trial a new technology, and then we observe people who actually use the technology for quite several, sometimes maybe like in a 3 months or 6 months or something like that, and to find respondents to do the research is not easy. That's the most challenging part. For example, we some people say, okay, 20 people is enough for the research, for example, but most of the time 20 is not enough. 20 is not enough. Usually we need more than hundreds of respondents to create a very objective result of HCI research. And sometimes also, but it depends on also on the topic. Yeah, so for the survey, okay, maybe like 250 or something. But for the trying a new technology, for example, like I have a friend who's research in the neuron technology using AR. Maybe he only needs like 20 or 30 people trying the device, but still there is a condition when bias arise because of the subjectivity of the um, users. Yeah, that's the most challenging, I think.
Okay, any more questions from students?
Anyone want to ask? I'm very happy, like some of the questions are very good.
I hope they don't use ChatGPT.
If they use ChatGPT, they can ask the ChatGPT the answer too.
Okay, one more question, Doctor.
Okay. What is your opinion about reliance on technology leading to decline in critical thinking and problem solving abilities? Oh, this is talking about ChatGPT, of course.
You have
Okay.
to type for the answer.
This is actually quite interesting because in here, like in my campus, we talk about this. Like, why students right now it's kind of very reliant, like have a dependent on the softwares like ChatGPT, you know, so that it can decrease their critical thinking and problem solving abilities because they are becoming more, how to say, they don't want to think. I can say that, right?
Yeah.
And my opinion about that, it's like when we see Google Translate. The first time Google Translate arrived, like they opened, Google Translate is also AI, right? A new technology. Google Translate is a tool. Everybody who want to use English, I mean, writing something in English, they can use English or other languages. They can use Google, right? It's a tool. And then when we talk in a English course,
Hmm.
students got their assignment, right? They use Google Translate. However, the teacher, they gotta be better. I mean, they gotta be more, um, have innovation more to to teach students, because the tool can help students to learn to do their assignment, but not to learn English. And that's what happened with ChatGPT. ChatGPT is a tool, but is it really true what ChatGPT said? Is it really true? Because like the apps like ChatGPT or Poe or Bing AI, right? There are a lot of applications like that in the world. They work based on data. They work based on data. If the data on the internet is limited, then what they say, what they answer, most likely to be limited. So it means that when students or people who use those apps, yeah, the technology to learn about something, they gotta be more critical rather than accept what those technologies say. They gotta be more critical. They gotta be more, how to say, like finding out the truth of what the technology said, because sometimes that's not true. Sometimes what they say is not true. However, most people think that what the technology said is ultimate truth, and that's what we need to break this condition. I mean, the perception of this must be broken down. Yeah, and how can we break the reliance of the technology? We cannot. As a human, we rely on the technology since the beginning of time. Since the beginning of time, we rely on technology. Like for example, now we relied on Google, right, to have our meeting today. So what we can do is that how can we protect ourselves to learn more, to be more critical about the things that the technology help us to do. I think that's my opinion.
Right, thank you, Dr. Intan, for the answer. Very, very good actually. For the interacting with students. Any other one last question maybe? Or if there's none, then I think we end the session. Any more? Last question?
Last question.
Everybody is hungry already. Okay? No more? Alright. So before we end, can we have a photo session?
Yeah, of course.
Okay, student. Alright, student, can you turn on your camera, please? Just one or two picture with the Intan.
Let's take a picture together, guys. Open your camera. Maybe we can meet directly maybe next semester. How about
Yeah.
that?
Good, that's good.
Usually we're like that, right?
Yes. If you're coming, of course.
Yeah.
We'll arrange face-to-face talk.
Yeah.
Okay, come on, guys. I can see Zarif, Shazwan, Shami. Lagi? Come on. Okay. Aiman. Okay, come on, guys. Just few seconds. Dr. Intan also would like to see you. Alright. Okay. Some of you are very shy.
Very shy. I think it's almost the same as my students here. You guys are too shy to show your faces.
Yeah. Just keep them. Okay, that's fine. Those who doesn't have any camera, that's okay. Okay, anymore? Otherwise, we can just take. Okay, ready? Smile. Okay, 1, 2, 3. Okay, one more. Okay. Okay, one more, guys. 1, 2, 3. Okay. Oh, it's a shame that you cannot turn on your camera, but that's okay. I think all of you did great today. Okay, so you understand what the importance of, actually first you learn about the HCI. Probably this is the first time for you, which is good. Now you can relate it with embedded system. Okay, your course, which is, I think that now you understand how important to have HCI inside any embedded system. Okay, so we would like now to thank Dr. Intan Zikria for giving us, I think, very good information. Okay, for me also. Okay, so I have learned today a new thing about relationship between HCI and also embedded. Although I have listened about your talk about HCI before, but now it opened my mind, further about the relationship with the embedded. Okay, so thank you so
Yeah.
much, okay, Dr. Intan, for sharing
Thank
your
you, Dr.
knowledge.
Intan.
No, it's my
And
pleasure.
this is
It's my very my
Dr.
pleasure.
Vidya,
Yeah.
the lecturer, actually.
Hi, Dr. Intan. We want to thank you lah to
Hello.
Dr. Intan for being willing to lecture our class today. There's a good topic lah to discuss and have our new knowledge lah about the human computer interaction HCI with embedded system. Last but not least, we thank you again lah and have a nice rest today.
It's my pleasure. It's my pleasure.
Thank you, Dr.
Thank you.
Vidya.
Thank you so
Yeah,
much.
she's
Right.
the coordinator for this course, actually. I'm just
Oh,
helping,
yeah.
helping in the lab.
We will meet again lah.
But yeah, inshallah, we will meet again. Maybe next
Yeah.
time you can join my class to
Inshallah.
teach in my class. How about that?
Ah,
Good
yeah,
idea.
that will be interesting. Yes, students are now thanking you.
Yeah,
So,
thank you so much,
thank you,
everybody.
everyone. Okay, see you again. See
See
you,
you
Dr.
again.
Intan.
Bye. See you.
Bye.